Ladies and gentlemen, hi, my name is Ted Gutiérrez. You are watching the Business of Cyber Show, and it's been a couple weeks since our last episode, but I'm really excited to talk about cyber-informed engineering. I am joined by Mr. Andrew Ginter. Andrew, welcome to the show. Thanks for taking the time out to talk about CIE today.
Thank you so much for the opportunity. I think it's an important development. I welcome a chance to get the word out. You know, I am the host of my own podcast, but on that podcast, it's all about our guests. I don't get to talk about what's important to me. So you're giving me an opportunity here. Thank you.
I love it. How many episodes are you at now?
We're at 130.
That's unbelievable. So I remember somebody said to me, hey, I want you to start a podcast. And I said, well, what should we do the podcast on? I said, well, you're going to do it on the business of cyber. I said, well, I love that. And you don't really feel like you have a podcast, and we're on number like 45. And one day you don't really feel like you have a podcast or you have much to say. And the next day you have 130, I have 45. And you're absolutely right. We don't get to talk about ourselves too much. But yes, this is the opportunity for you to do that. We want to hear about your new book. We want to hear about what you're doing on a regular basis. There's so much great information available in engineering grade OT security. I got 2 copies. I sent a couple more copies to folks on my team. Really excited to talk about this today.
Cool.
Let's dive in, shall we?
I'm delighted to hear it.
Perfect. So for those of you who don't know Andrew and maybe haven't been a part of the Business of Cyber Show, let me give you a little bit of an overview. So Andrew and I have done a couple different podcasts together. I'll slide over to talk about his experience so that you know kind of where he's coming from. But the reason that I'm excited to have him on the show is he's an ultra engineering minded and tactically and technically focused individual supporting the industry. And that's not usually the type of content that we have on the Business of Cyber. Where the Business of Cyber show came from was this realization that in the industry, there wasn't enough time, there wasn't enough qualified people, and there just aren't enough dollars inside of budgets at the asset owner level for us to really attack cybersecurity the way that we want to. And so I dedicated a podcast show once a week to bring on guests to help us understand how can we maximize the resources we have very few of. And so for Andrew to come on board and talk about CIE, to talk about network engineering, to talk about how cybersecurity can really be improved from design all the way to implementation, this is a really a great treat. So today we're going to be talking a little bit about my 2 favorite standard / programs, NIST CSF as well as ISA 62443, maybe how they relate a little bit. We're going to be talking about engineering in general in cybersecurity, and then we're going to finalize with some real concrete examples of CIE. But before we do that, Andrew, tell us a little bit about yourself so that the audience knows kind of your background.
Sure thing. Thank you for the opportunity. You know, I'm with Waterfall Security Solutions. They gave me a fancy title of VP Industrial Security. I work with a small team of subject matter experts. You know, within Waterfall, we're a technology vendor, a cybersecurity technology vendor. We have a whole team of solution architects that are gurus on our technology, unidirectional gateways. If you need to do something weird with them, they know how to do that. I lead a much smaller team, and our focus is not how do you do high availability with bandwidth restrictions on a unidirectional gateway. They are, you know, my team is focused on the big picture of security, regulations, standards, you know, relationships with post-secondary institutions, the big picture, and, you know, where Waterfall fits within the big picture. And, you know, to that end, we run our own podcast, and it's about a guest that we bring in talking about security. I've had you on the podcast. Thank you, Ted. Talking about, you know, your piece of the elephant. Like you said, it's been humbling. It's you know, I thought we had maybe 50 episodes in us when I started the podcast. And, you know, I measure an episode as it's a good episode if I learn something. I figured I've been doing this for 20 years. If I learn something, probably everyone's going to learn something. Well, there's a lot of faces to the elephant.
The goal in all of it.
There's a lot of faces of the elephant. It's been humbling to find out how much I didn't know.
So do this for me before we dive into kind of some of the topics. Engineering grade OT security. Is this your first book? What kind of was the idea behind it? Give us some backstory, man.
So this is my third. You know, my first book I wrote sort of for selfish reasons. I wanted to believe that I knew enough that people would write, read a book that I wrote. So I, but I had no idea how to write a book. What I knew how to do at the time was write really long, painfully long blog posts that nobody would read more than the first 10% of. So I wrote 13 of them and called them chapters. And I got feedback. It was a learning experience. The feedback ranged from, Andrew, I disagree so fundamentally with your premise that I could not finish reading this thing, all the way through the other extreme of Andrew, it must have taken weeks of your life to write this stuff. But everything you've written is obvious. What would possess you to spend so much effort documenting what is self-evident? And so I learned a few things. One is that experts disagree. There's no consensus. And, a second thing I learned is nobody likes a critic. The subtitle on the book says it all. The title is SCADA Security, a critic.
Yeah.
The subtitle is What's Broken and How to Fix It. I criticized. And so everyone I criticized, I thought I could show people the light and they would follow me to the light. No. You criticize and people get there.
But you can't make it drink.
No, they get their shovels out and they start digging deeper.
I tell you, it's an interesting paradox, right? We train people on how to fix things. We identify something's broken, but whether it's politics, whether it's resources, or whether it's something else, I see cyber programs failing to mature very, very often. And this concept of going back to the engineering level, the design level, I'm actually really interested to learn, because I think sometimes we complicate cybersecurity a lot. I think there's a lot of fear, uncertainty, and doubt that a lot of, really big product companies are now pushing. And I think, I'm curious if you think that a lot of the threats and the attack surfaces are really as wide as one might seem. That's why I did share it. I really like chapter 3 because it simplifies that. Well, very good. So what was the second book, just out of curiosity?
Second book, I sort of was a reaction to the first. I said the first one didn't really accomplish what I wanted to accomplish. And so I wrote something. I swung the pendulum to the other extreme. Instead of criticizing, I said, we work with the world's most secure industrial sites. They ask different questions. They look at security a different way. They do things differently. I said, someone has to document this. No one else is documenting it. They're all documenting sort of small shoe factories. And so I wrote the book documenting what I observed our customers doing differently. And I wrote it sort of as a journalistic style. Here's what they do. First, they ask this question, then they take this answer, then they do this, then they do that. If you see value in any of this, you pick it. You pick and choose whatever you think you. And the feedback I got was, this is all good stuff, but when would you use this stuff and not that stuff? When and what kinds of systems would you use these for, and why? How do I choose? And so that was the second book and it was very technical. The second book I describe as, if it's a jet plane, it flies low and fast. I was pressed for time, so I said, I'm going to assume what HMI and man in the middle and device driver and all this stuff means, and I'm just going to use the words. Here we go. And so the third book, the feedback I got from both books was, the chapter we like most is chapter 2 of the Red Book, where I introduced stuff. And I said, why don't I write the third book as a manager's guide in the style of chapter 2 and address the question that came out of the Black Book, which is, how much is enough? How do I know how much engineering to do, how much cybersecurity to do, for which kinds of systems, and why? And that was what I tried to address.
Well, and that leads into the first of 7 chapters or subtopics here, and that is, why did you choose that title? I think that's a very, very interesting title, and I see it. Who would you say is the core persona? Somebody says engineering grade cybersecurity. Are we speaking to engineers, or are you speaking to all folks and trying to distill down what engineering grade security can be in its most simplistic fashion?
I'm trying to speak to everyone, and
Okay.
the we might be taking your questions out of order here, but um, a a thing that to me that I think is very important is to sort of the current state of OT security is cyber informed engineering, an initiative out of Idaho National Laboratory. They position it as a coin with two sides, as engineering on one side and cybersecurity on the other, working together. Um, and they talk about engineering style mitigations. And so one of the things I do, I mean, I document what I learn from people like you on the podcast. Thank you. I document what I see our customers doing. The one thing I do sometimes is make up terminology so that everyone calls something by a different name. I try to, make up a name that's going to work. And so if we're talking an overpressure relief valve, a mechanical spring-loaded valve, if a boiler overpressurizes, it forces the valve open, the steam escapes, and there's no explosion. That's an engineering mitigation. And I use the word engineering grade, and I don't define engineering grade. That's a criticism I've had of the Gold Book. I welcome feedback. I haven't defined the term engineering grade, but loosely, it means mitigations, tools to address risk, to address threat that are deterministic. Okay, the valve has a spring. It's going to behave the same way every time the pressure increases, unless it's broken with corrosion or metal fatigue or something. It's deterministic with mathematically modelable failure modes. So, again, with an overpressure relief valve, again, I oversimplify, but the textbook oversimplification is called a bathtub curve, where if you buy one of these devices, it will fail at random. And it tends to fail, has a higher rate of failure early in the life cycle, let's say the first 6 months, due to manufacturing problems, manufacturing defects that are manifest early in the life of the thing. And then it sort of settles down and fails rarely for a period of time. And then it starts aging, and it starts, sort of the failure rate ramps up again. This is the bathtub curve. You can model these things mathematically. If you have 4 of these things in parallel, you can mathematically model the combined failure rate. This is what I determine as engineering grade, and very few cyber mitigations are engineering grade. This is sort of the engineering side of the coin that's been neglected. And I wanted to emphasize that side of the coin in no small part because Waterfall produces engineering grade mitigations for threats coming across networks. And I've struggled for a decade to try and figure out how to position our stuff within the space of cybersecurity. And now I've figured out that there is this whole thing of engineering that, cyber-informed engineering brought to light, going, wow, this is important. I've actually seen our customers doing this. They didn't have a name for it. And now I can position our stuff as sort of at the boundary between engineering and cybersecurity. And people look at it and go, well, that makes perfect sense. So to me, in a sense, it's self-serving. I do this to try and figure out where we fit. But in order to figure out where we fit, I have to try and document the whole space. And I'm delighted that other people are finding value in that sort of simplified picture of the whole space.
Interesting. So a couple comments. I like what you're trying to say. So you're talking about looking at the actual engineering grade level, if you will, of the various component systems within various zones of our critical environments. And we are trying to identify, let's say, for a lack of better terms, the weakest link, and then kind of reapproach our cybersecurity concerns with that weakest link in mind and connect them to a business outcome that is meaningful to the organization. Instead of saying cybersecurity across this whole blanket of everything we do, you're trying to drive more specificity. So is that fair?
So that's certainly part of it. It's a big picture, and yes, that's an important part of it.
Well, and so how I got into cyber was because of risk management. I got into risk management because of quality assurance. Quality assurance was started by quality engineering. Quality engineering was started by root cause failure analysis of downhole tool systems. So this is really speaking to me, right? We used to do non-destructive testing. We need to do ultrasonic testing. We used to do evaluation of every moving part in a downhole tool in a drilling environment and say, which one of these is going to break first? How do we re-engineer our quality program so that it doesn't do it? Very, very interesting. So if we wanted to map, and going back to, I think, what was our second topic, if we wanted to map engineering on top of the most widely used framework in my book, which has over 100 control families, over 100 different questions, tons of different variables, not a lot of shall statements, but a very, very good guide that I think over 60% of our clients use on a regular basis to assess themselves to a certain standard or framework. Where does NIST CSF stand with CIE?
Let me give you the short answer, because I'll drone on the long answer for a long
Sure.
time. The short answer is the NIST CSF is about cybersecurity, and the CIE umbrella encompasses a lot of pieces of engineering and most of cybersecurity, all of it that's relevant to physical operations. And so the NIST CSF fits under the CIE umbrella as a proper subset that has to do with cybersecurity. And I say that, people say, well, what's the difference again? Where in the NIST CSF, which of the statements, which of the rules in the CSF, and this is the let's say version 1.1 CSF, where does it talk about overpressure relief valves? No mention of them. Where does it talk about manual operations as a fallback for, if you can keep the refinery operating manually, producing gasoline, even if all of the automation shuts down, that's a powerful tool to address the threat of cyber sabotage. Where's that mentioned in the CSF? Not a hint of it. Where is it in, IEC 62443? Not a mention of it. These are all cybersecurity standards, whereas manual operations and overpressure relief valves and breakaway clutches, these are engineering mitigations for various kinds of threats and risks. And so they're two different animals, and they all fit under the umbrella of CIE.
See, I could actually map, just off the top of my head, if we start thinking about a critical engineering level control, we may not be talking about a spring, but if we can map to NIST CSF on managing and accessing user permissions or authentication mechanisms, which are extremely clear, they're umbrella oriented in NIST CSF, but would you not agree that that is an example of connecting the two?
I would disagree, but that's just me. I distinguish between the permissions are a software thing,
Right.
whereas the point with software is, I wrote software for 20 years. In
Right.
spite of my best efforts and the best efforts of all of the teams I ever led, I ever was part of, all of my colleagues, every piece of high quality production level control system software we ever produced had defects in it. And some of those defects were security holes. Some of those holes, our enemies had discovered and were using against us. Some of them we had discovered and were madly trying to patch. That's the nature of software. How do you compromise an overpressure, spring-loaded overpressure relief valve? The only way to do it is physically. If you're there with a hammer, you can compromise it. There is no way to do it software-wise. There are no vulnerabilities. To me, I see them as qualitatively different kinds of mitigation. Now, not to say it's not important. People misinterpret. I emphasize the engineering side of the coin because I think it's been underemphasized in the past and deserves to be highlighted. But it's a coin. When we spend a coin, we don't spend one side of the coin, cybersecurity, or the other side, engineering. We spend the whole coin.
Right.
When I ask people, if your life depends on a 6-story boiler not blowing up in your face, how would you prefer to be protected from a cyber attack that overheats the furnace under the boiler? Would you prefer an overpressure relief valve, or would you prefer a longer password on the PLC controlling the boiler?
So you're operating within the realm that a cyber attack, let's not say is inevitable, but if our lens that we're viewing is that a cyber attack is going to happen at some layer, at some element of our overall engineering systems. What would the engineering decisions I would make, how would they be different? Is that's a fair assumption of how you're thinking about it?
That's part of it. Let me deliver the punchline. The punchline here is the truly in the know say, Andrew, you're deceiving us. You're asking the wrong question. I want the overpressure relief valve. I want 4 of them because there's, the possibility of corrosion or metal fatigue. I need one of them to work. And I want the longer password. And I want an absolute boatload of cybersecurity beside it. It's not an either or decision. What we're saying is that the engineering community has powerful tools and approaches that have been neglected. If all we do is look at the cybersecurity framework and say, have you got network segmentation? Have you got policies and procedures? Have you got, some I don't know, anti-malware in there? The possibility of subtle changes to the physical process or even the design of the automation systems, subtle changes that take entire chunks of risk entirely off the table, those are the tools the engineers have in their pocket. And I see some engineering teams using those tools consistently, but they're not being used universally. They're not being used across industries, across organizations. They're not being used systematically. And to me, this is the thing that's the CIE initiative is trying to build a body of knowledge saying it's not just cybersecurity. The NIST CSF is important. I see it as one of the most useful innovations in cybersecurity in the last half decade. But CIE is about this whole other class of tools that we've neglected.
Well, I think I see where your head is at. I understand what you're saying. Do you think that we have become too siloed as we think about risk in the average asset owner? So you have your engineers that are on the very front end of building. They're on the greenfield side. You've got other teams that are acquiring all types of new assets, and they're having to refurbish. Then you've got a cybersecurity team who is undoubtedly doing some element of assessments. For a period of decades, we've somewhat siloed these organizations because they need autonomy from each other. How do you feel when someone says cybersecurity should be its own function, where someone else might say, if I can incorporate the theory and the intent behind a NIST CSF into my engineering, it's a much lower resource, higher bang for the buck outcome? I could get behind that. What say you, sir?
Absolutely. It's a truism of the industry that, the enterprise security, cybersecurity people and the engineers don't talk to each other, or when they talk to each other, bad things happen.
I call my job marriage counseling for OT and IT.
Absolutely. And it's the reaction I'm getting with the CIE message is that, this is a really useful way of looking at it. It simplifies this relationship thing. So, let me give you an example. Imaginary company. The CEO says to the CISO, the engineering group has done a lousy job of cybersecurity for our massive, expensive assets. OT security is now your job. Do it. So, sends the people in there, and the first thing they say is, "What? Look at this mess. Patch everything." And you get this. You get collision. To me, the first step in sort of solving that is for the engineering team to come back and say, "Okay, I'm happy to do that, just as soon as you can tell me how likely that is to kill anyone." What?
That right there is the conversation in a nutshell that every organization is having right now. Let me ask you another question.
Well, but if I may, there's the other side of the coin. So that's the sort of the piece of the puzzle that cybersecurity needs to wrap their head around, is that This is a different animal. But let me give you the other side of the coin, which is, sorry to interrupt, is when the IT team, the security team comes up to speed and says, oh, engineering change control, that's a problem. Their next question to the engineers should be, well, if you can't patch to address the threat of people dying because of cyber attacks, what are you going to do to address that threat? And they're going to go, threat? Because the threat has evolved dramatically in the last 10 years. And it's simply not been on the radar of engineering teams. And now it needs to be. So they need to come up to speed on the threat. In my experience, once you take an engineer or an engineering team and you teach them how much trouble they're in, they start demanding cybersecurity. And they start asking questions like, well, what can I do? Well, you can put some antivirus in, but it'll only solve this much of the problem. You can do some patching, but it'll only solve that much of the problem. They're going, give me that knowledge. They're going to pull it across so that they can design a system that addresses the threat adequately. And they have their own deeply entrenched standards as to what adequately means. And really, they're very demanding of the standards, on the engineering side. So to me, if you can get these teams talking to each other and each of them recognizes a gap in their own understanding and they start cooperating, now you've got a powerful thing happening in the organization.
Yeah, I think it comes down to effective communication starts with effective recognition of how do these people think about their outcome of their job? What are the variables that go into it? I think in layman's terms, cyber people shouldn't go to the OT folks saying, here's all the things you need to do about cybersecurity. You're rather saying the cyber folks should go to the OT folks and say, hey, look, we understand that this was engineered a certain way, but you have to understand that the threat models are just different now. So we've overlaid some threats. We've identified that here are all the potential things you can do. We're giving it back to you and we want to help. How can we be of service? I think that's fair. I think the critical juncture there is how many of our cyber trained folks understand what that chemical facility or what that water treatment facility, how it really works. And I think, that to me is where I'm a macroeconomics guy. I always want to talk about the economics of this space. I think we've skewed the economics because we're not incentivizing anybody to teach or learn or execute that level of communication, Andrew. I think that we have rather said, let's build as many solutions as we can, whether they're service or product oriented. And let's go in and blanket the OT and the cyber teams saying we have the solution, when in reality, I think we might be overspending in a lot of ways. You're looking at it saying, well, if the OT and the IT teams can work together better, there may be a lower, we may not need as many solutions. We may not need as many incident response exercises or assessments. I'm on board with that.
Absolutely. The CIE folks at Idaho National Labs, they talk about an experiment they did in the course of developing what they're working on. They put a classroom full of volunteers, and they didn't say who they were, but I kind of got the sense that they were mostly, think of them as sort of Active Directory administrators. That sort of, they understood cybersecurity. Put them in a room, taught them CIE, gave them a network diagram for a fictitious small power distribution system, and said, apply the principles. Let's see if this works. And the first step is assess the consequence. What's the worst thing that could happen? Because that will drive decision-making on the security side. And they looked at the network diagram and said, I've heard of the possibility of a cascading failure. That's what happened in the Northeast in 2003. It wasn't cyber. It was a failure where if enough of the grid fails, the rest of the grid just drops.
Right.
Is that a credible outcome of a worst case compromise of my distribution system? And they looked at each other and went, I don't know. And I looked at the network diagram. They didn't even have where the protective relays were in the network, which are sort of the tools that are essential to preventing such a cascading failure. The wrong people were in the room. So I think one of the lessons is that if, overspending, if you don't understand the physical process, you're going to have to make some assumptions about worst case scenarios that may not be justified.
Mm-hmm.
If you have the engineers or the other knowledgeable people in the room, they can say, no, 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 that boiler can't explode by overheating the furnace. We've got pressure relief valves on there. Oh, well, then we can take that off the table and, potentially reduce the spend. But they can also come back and say, but you haven't considered X, and that's really bad. Oh, well, then we should refocus on X. And, it takes a village to do OT
Yeah, it does.
cybersecurity.
Well, when is the right time that engineering projects should start thinking about cyber?
And this is one place where I disagree with what's been written by Idaho National Laboratory. They've said a few times, the right place is right at the beginning of the process, and to an extent they're right. So let me explain first how they're right, but I will disagree as well. They're right in the sense that people say, oh, but if I put focus on cybersecurity too early in the process, then it impairs innovation, because I have to focus on the innovation first and then do cybersecurity afterwards. Well,
Mm-hmm.
if I'm designing a new way to produce electric power at scale, we're talking massive deployments. They're going to anything done at scale is dangerous. That's powerful tools are dangerous. That's because they're powerful. If I'm focused on and I've lost my train of thought.
No, it's okay. You were talking about Idaho National Labs thinks you should start cyber at the very beginning.
Thank you. Yes. Okay. So we're doing it at scale. Anything done at scale has safety threats. When you are designing in any kind of innovation, when do you start thinking about safety? Pretty early in the process, because if something's going to blow up in your face, it's not a useful innovation. And so,
Right.
When should you start thinking about cybersecurity? It should be pretty early in the process. It's essential to safety. On the other hand, I disagree in the sense that, yes, if we've neglected cybersecurity or safety until later in the process, if we've messed it up, we're going to have to fix it. You can't say, do it early, or throw your hands up and say, oh, I guess it's too late. We should have done it early. That's the wrong, and it's an extreme example, but let me give you the counterexample of the Boeing, what was it, the 787 MAX. They, had a problem with the redundancy of something to do with maintaining the attitude, preventing stalls, this kind of thing. And 2 aircraft fell out of the sky, killing everybody aboard. Did the industry say, oh, well, that's a design flaw. We should have fixed that at the beginning, because it would have been really cheap to fix it at the beginning. Too bad. Aircraft will continue to fall out of the sky. No. They said, ground those aircraft, ground them now. And they left them grounded until they had analyzed the problem, designed a fix, implemented the fix, tested the fix, certified the fix, deployed the fix, trained all the maintenance people on how to maintain the fix, and then they let them back into the sky. Right. Cost billions and billions of dollars. But they didn't say, should have done this at the beginning. So I disagree that it has to happen at the beginning, but it is always cheaper to do it at the beginning. And if it's essential to safety, it has to be part of the early stage design. It's not that you're going to make it the focus of your design. Nobody designs safety. They design a new power plant, but safety is there from the beginning. And so is security.
I think that where cybersecurity fits in depends, right? I'll give you an example. If I'm building a car, I'm either going to want that car to go very, very fast. I'm either going to want that car to be ultra safe, or I'm going to want it to last forever. But I can't have all three. So pick which one is, your North Star, and then build around it. I actually disagree that cybersecurity should be a major focus early in the engineering process, because I do think it stifles innovation. I run a software company. I think the more complex you make something, the more people that log into something, the more API connections you have with something. Yeah, you're obviously increasing your overall vulnerabilities, your attack surfaces, your threats, everything. But if you don't try to focus on the outcome that you're trying to achieve first and then secure it, then I think you do stifle some innovation. Where do you see, switching topics just for a second, where do you see secure development lifecycle as companies are building components, parts, widgets, let's say? And we could say software, or we could say hardware, or we could say the software residing, within a hardware. Where do you see this topic of CIE as it relates to component development?
So again, so let me back up. So we're going to talk from secure development lifecycle and sort of the big picture of CIE. Let me hit the big picture first. What I haven't said is there is another initiative out of INL called CCE, Consequence-Driven Cyber-Informed Engineering. And it's a book, and it's a methodology, and a lot of it, not all of it, a lot of it has to do with risk assessment. It's an extremely thorough way of doing risk assessment. And it's a proper subset of CIE. It fits under the cybersecurity side of the coin. It's part of the body of knowledge that you need in the room in order to be effective at doing OT security. SDLC, the short answer is it also fits as part of the cybersecurity side because it's focused on cyber assets as opposed to physical assets, which tend to be the engineering focus. But I have an issue, and again, when I write these books, I document what I see people doing, but often I'll make up terms. I look at the terms people have made up for secure development lifecycle, and they're using the word secure as an adjective, as if using the lifecycle would produce secure results. And I'm sorry, the only people who the people I observe most using secure as an adjective are you and me, because we're vendors and we're selling stuff that we call secure. Because security is a spectrum. You can always be more secure. It's like safety. Are you safe right now? Yeah. Could you be safer? Yeah. Could you be less safe? We could be doing this on a surfboard. Yeah, you can be less safe. The question, are you safe, has no answer, because you're assuming a yes or no answer in something that is a spectrum. It's the wrong question. Same thing with security. I hate it when people use secure as an adjective. Who invented the secure development lifecycle? It's, I'm sorry, a bunch of vendors like us who wanted to persuade their customers that what they had was secure. The question is not, the question, are you secure, is meaningless. The question, how secure are you, has an answer. The question, how secure do we need to be, is even more important. But that said, if we talk about software development lifecycle security, it's important. It fits under the security side of CIE. It is something that to your point, if you've got a gleam in the eye, you've got to, think about making the gleam work. But at some point, early in the process, you've got to think about, is there any way to secure this? And what does that mean? And would I use that for a high-speed passenger rail switching system, or would I use it only for, small shoe factories and their
Sure.
Nothing against small shoe factories, but there are what I've tried to do in the last 10 years, and I've struggled with this, I've tried to understand the dimensions of OT security. And I've identified like a half dozen dimensions, but I haven't written them down because they all seem to be the same thing. It's all about consequence. The most consequential sites, passenger rail switching systems, nuclear generators, need a certain approach to cybersecurity that is not justified for small shoe factories and toaster factories. And there's a whole lot more small shoe factories in the world than there are passenger rail switching systems. Other dimensions I've looked at are the sort of the dimension from IT style software-based security through engineering style overpressure relief valves. And they seem to match. You tend to use security and engineering most aggressively for the most consequential sites and less so for the other ones. I looked at that sort of IT versus engineering. I looked at I forget 2 or 3 other dimensions, and they all came out to the same thing. It all seems to have to do with consequence. It sounds like there really is only one dimension. And so to say, I've done secured software development, therefore I'm secure. Deploy me anywhere you want. It ignores the consequence dimension.
Right. I think that the biggest challenge we have in OT cybersecurity or making OT systems and processes and people and facilities safer is about a consequence oriented, which means that we're living in a lot of ways in the hypothetical, which is in the antithesis of an engineering minded workflow. And I think that is also, I think the problem is also compounded with the relative fear, uncertainty, and doubt around, or the hype around what could be true. I think we have folks that sit into a couple different camps. I think we have the engineering minded folks that say, man, I totally understand cyber is important and I'm on board, but that is this thing over here. I've been working here for 25 years. There's redundancy in systems. It's not going to blow up if somebody, doesn't patch that. And I think that's a camp. I think the other camp is a group of cyber trained professionals that are still trying to really wrap their arms around the vast nature of automation, OT, process oriented, just control systems in general. And then I think there's a third group who knows it's important, but has no theory or no training on how to effectively define it. Those are the ones with the budget, the people that implement it, the people that design it. And somehow, I think the next few decades is about how effectively do these people work together. I understand the engineering minded perspective you have. I do think that we're very aligned on the challenges that lie ahead. But it's a very interesting way to look at it. I'll give you we've been at it for about 45 minutes. And so I'd love to give you the last word.
Absolutely.
As you think about what you would want your book, let me rephrase that. As you think about this particular book, the third that's out there on engineering grade OT security, how would you describe the best value that you can hope that it offers the industry in the next 5 to 10 years, sir?
Well, the goal of the book, and it's not evident from the title, but it's there in the first chapter, and I sort of hit my best shot at the goal in chapters 7 and 8. The goal is to give us a decision process to figure out how much is enough, how much security, how much engineering. And it's not that you're choosing one side or the other. It's that you spend the whole coin. The sites that I see using engineering most aggressively to deal with cyber threats also use cybersecurity most aggressively. It's not either or. But I would hope that the book is a step in the direction of answering the question, how much is enough? And I think that's, in a sense, that's the question for the ages, because, even if we can get engineering and cybersecurity to agree, we still got to spring the money loose. We still got the other stakeholders that we've got to convince, and you're not going to do it with numbers and with so and in fact, the feedback I've got on the book so far is that chapter 6 is weak. And it's the one where I talk about cyber risk. They said, you got the right ideas in there, but then it falls apart later in the chapter. And I've been taking that to heart and talking to people about what's missing, and I think a word that's missing is the word credibility. So when we talk about cyber threats, we talk about the assets, the consequences, the targets, and we talk about the paths between the threats and the targets and what we could do about those paths, engineering wise and security wise. It's not true that every possible attack has to be mitigated. What people actually do is they mitigate those scenarios they regard as credible. And if we start talking about credibility instead of likelihood, I think it becomes a better informed conversation with the business decision makers. So I'm working on, trying to fix what I got wrong in chapter 6. I invite everyone to have a read at it and give me some feedback. I rely on feedback, as you can tell. But what I hope is that in the long run, we've got, CIE has got engineering and other teams working together, and with sort of a different way of phrasing the problem, it will be possible to persuade our business decision makers that we're doing the right thing and that it deserves funding. And the reaction I've got to CIE so far has been, you've got the same puzzle pieces, you're putting them together in a different way. There's no air between them anymore. We used to have all sorts of air between them. There's no air between them. This finally makes sense. Here's the money, do it. So that's kind of, again, be my 75% reaction. So that's what I hope, is that we can persuade people to do the right thing.
Makes sense. Well, Andrew, thank you for joining the show. I think that the engineering-minded voice that you offer to the industry is an extremely helpful one. I appreciate your humble approach, and we look forward to having you on the show in the future if you'd grace us with your 4th book. How about that? Deal?
Deal. Absolutely. Thank you so much. It's been a great pleasure, great honor.
My pleasure, man.